After taking the derivative using the definition over and over again, you have to start to wonder, are there any shortcuts that could make this easier? Well, good news, there are. We're going to take a look at the derivatives of polynomials in this video. First, to set it up, though, some basic formulas for derivatives. Let's look at some rules, and we'll look at some examples of that rule. So the first rule is if I want to take the derivative of some constant value, like 5, 7, pi, or e, the derivative of any constant turns out to be 0. So for example, if I wanted to take the derivative of the number 7, that answer is going to be 0, which kind of makes sense. The derivative measures how fast something is changing, and the number 7 is not changing at all. If I wanted to take the derivative of just the variable x, that derivative is going to equal 1. Well, that's not much of an example, but it is the example. The derivative of x is equal to 1. Another nice rule is we can take the derivative of some constant times a function, and that will be equal to the constant times the derivative of the function. In other words, if I want the derivative of maybe 7 times x, that 7's the constant, and it gets multiplied by the derivative of just x, which is 1. In other words, we end up with just 7 in this case. One last basic rule is if I want to take the derivative of one function plus another function, that's equal to the derivative of the first one plus the derivative of the second one. So for example, if I wanted to take the derivative of 7 plus x, I could take the derivative of 7, which is 0, and add the derivative of x, which is 1. And the overall derivative rate of change here is going to be 1. Those are our basic formulas for finding derivatives. Some more interesting formulas to us, though, are going to be particularly about polynomials. With polynomials, let's take a look at the rules. With polynomials, I can take the derivative of x raised to some number. And the way we're going to take the derivative is you can move that exponent to the front and reduce the exponent by 1. In other words, if I wanted to take the derivative of x raised to the 8th power, we just have to move that 8 out front and then reduce the exponent by 1, and we're done. No need to go through the big limit definition. And we can combine this idea with this third derivative rule with a constant out front is just a constant times the derivative. So in general, if I've got a constant times x raised to an exponent, we take the constant times the derivative, which is the n times x to the n minus 1. In other words, you're going to multiply the constant by the exponent. In other words, if I've got the derivative of maybe 5x to the 9th, I can move the exponent out front. 5 times 9 is 45, and reduce the exponent by 1 to get my derivative of 45x to the 8th. So let's take a look at some examples of us taking derivatives of polynomials. Let's find the derivative of 13x to the 4th minus 7x cubed plus 2x squared minus 5x plus 3. Well, we take the exponent and move it to the front, and then reduce the exponent by 1. 4 times 13 is 52, x to the 3rd. Again, bring the exponent out front and reduce it by 1. Negative 7 times 3 is negative 21, x squared, plus 2 times 2 is 4, x to the 1st, minus 5 times the derivative of x, remember, is 1, plus the derivative of 3, because it's a constant, is 0. And this, then, is our derivative. Let's find the derivative of 3 over x to the 7th. This doesn't look like a polynomial, but it actually is, because we could say we're really trying to find the derivative of 3 times x. And what puts the x to the 7th in the denominator would be a negative exponent. So now that I've written it as a polynomial, we can multiply the exponent times the number out front and reduce it by 1. 3 times negative 7 is negative 21, x to the negative 8th. In fact, we can use this trick to rewrite exponents on things like radicals. We can take the derivative of the 4th root of x cubed. Well, the index is the same as the denominator on the exponent. So we're really taking the derivative of 3x to the 4th. Well, now I can move that exponent out front and subtract 1. And 3/4 minus 4/4 is negative 1/4. And we can leave it like that, or we can rewrite it as 3 over 4x to the 1/4. Either way is just fine. I'd probably keep the negative 1/4 as my final answer. So let's do one more example where we put it all together. And we're going to find the derivative of 4x cubed minus the square root of x plus 2 over x cubed. Well, before we find the derivative, let's actually rewrite everything with an exponent. So we have 4x cubed minus x. It's a square root, so it's 1 over 2. The index is the denominator of the exponent. Plus 2x, and when we bring the x cubed up, it becomes a negative exponent. Now we're ready to use our polynomial derivative rule. 4 times 3 is 12. X squared minus 1/2. X to the negative 1/2. Minus 2 times 3 is 6. X to the negative 4. Bring that exponent out front and reduce the exponent by 1. Our next video is going to take a look at what polynomial shortcuts we can take when working with exponential and logarithmic functions.